Okay, welcome back. So move diagonal up, again using negative down, not negative, but negative speed to go higher up, since higher up is closer to 0, and then the actual direction multiplier, so either left or right, but in this case, yeah. By the way, direction multiplier of whichever way you spawn going, and then multiply that by speed to go on your x. Same with your down, but going downwards with a positive speed on the y-axis. Upfill is a random out of 4 to fill it with either any of the 4 movements. Same with downfill, but in the opposite direction. And then, that's regular fill. Downfill is specifically only for the down orders. Upfill is specifically only for the up orders. Off screen is similar to Scorpion's off screen in that it kills you in a specific order for deregistering, marking for destroy, calling to stop, and recalling the timer for your spawn, your alarm to then spawn. This is the chunk of code I created for motion destroy. Originally, it was just check your current position to destroy the mushroom at that point, but that only worked like 2 out of the 10 times I've tested it. So adding these else ifs to check half ahead and half half ahead and half behind while you're moving. While it is extra checks, it makes it feel more, but it smoothens out the actual way to mimic a collision with the mushroom, in that it but essentially whenever the main body hits a mushroom, it will delete it. And then with an update, you call mushroom destroy to check, and then your order queues, you fill it if it's empty, and if it's not, you're basically either downfilling or upfilling based on if you are above or below the bounds you're allowed to move, which are the same as your standard player bounds, just slightly above. Again, there's your order, pop, fun stuff. And here is, if you're off the screen, call off-screen destruction steps to follow. Draws your standard draw. Your destroy only calls empty queue and deregisters, so that it sets it up for the factory to properly utilize it. And the wave manager then calls spider destroy to notify the wave manager that it's dead, essentially. Here's your initialization. Upon initialization, you choose your random for your direction, which is a ran out of 2. So if it's 0, then you're going left. If it's 1, you're going right, and it changes your the direction multiplier accordingly, as well as switching you to your specific spawn side, which I've set up again all within my common file, which I'll show you later, which again you probably don't like, but whatever. And this is also where you call play to start, since it's on a loop. Collision with bullet, you kill the bullet, report your death from yourself, which is position Y, as well as the player position, and we'll get into that in a second. So you also call stop, mark for destroy, and reset the timer. Wave stop, you set your speed to 0, and again pause, clear the queue basically, and then sound manager spider stop sound, so that you don't play sound. If we peek at this, so this is like many of the standard, but instead it also considers near, medium, and far. And upon near, medium, and far, we consider, we create a temporary answer of int ants equals self minus y, so the distance between the player and the spider when the spider is killed, and it checks if it is any of these distances set up within the actual command distance subsidiary, which we'll get to after this actually. So yeah, so if it's I forgot the actual ranges, but close range is 900, mid range, which is being close and far, is 600, and far range is, once you're at the cusp of far, you set it to 300. And that's essentially that specifically for that factory. The rest of the factory is your standard with terminate, so proper garbage collection, as well as a lot of code showing me testing a bunch of stuff, which is not new. Alright, so we were going to talk about score management. So my actual score manager has a lot of data in it, in that it has what was similar to the sound manager of the get score commands for all the different numerations. So the numerations that we set up is here, and we set that all to specific distances, distance point value pairs for a specific spider, but everything else has your score values set up here, which were originally set up in my common file, but seeing the way you set up Score Manager, I just went with this and overwrote what I said in my common. Anyway, I also take in high score, some lists, and processing, current score and high score, and then here we have send score. This is where I have my loading method for the high score file, since I'm reading from a file and loading into a file. So that's where I have that. So we could go there real quick. So this is a standard get score command, just to set your proper command score pointer to the relevant amounts. Add score then calls to player manager, which is in control of the current player score, to add to it, and then set score sends it to the stack to be processed. Processing literally calls execute, which is then calling add score, which is then this. There's the score loop with the different pairings. And then here's load high score, which is somewhat messy, but I hope you'll understand how it works. So here you make the master copy, make sure it's empty, take in a file, fill in the file, not the file, but you fill in the copy with the master copy with all the data from the file, and you close it, and then from there you get the number 1 score and send that straight to the update high score in HUD manager, so that the starting high score is the one that's on top of the list, and then you call it to high score set within player manager for later processing, so that you always have the highest score to use when you're doing the computation for input high score. Here's just simple code for send username, send score, copy high score, pop it, turn the minimum to the back of this, which is used to test for the qualification, but instead of this I overrid it so it uses the very top high score for qualification. And here's your insert high score. Here's where it gets somewhat messy. So you take the input and you take the actual score and you throw it in this very crazy while loop. So it starts out with a boolean false, and you compare everything in it, and it only kills it if you break the high, if it breaks it, or if it doesn't break it. It only breaks out basically if you meet one of the conditions of either going through the whole list, or if you make it. not make it, if you don't make it to the high score. Yeah. And then from there, you take it all back and start pushing the values back in, basically just to reorganize the actual high score list, and then push it back into the actual temp, and then from here, create my list. So yeah, basically use that to push it into the temporary, and then recreate the whole rest of the list by popping it all back. Not popping it all back, but setting it all back to the master to fill it in. And then you open up the high score file and input your new high score, and then close it, and then you call load scores again, so that when you go back to the attractor mode, it sets it all up correctly for the title screen. Title screen, attractor mode, player list. Alright, so yeah, that was Score Manager. Here are the physical commands. Here's the base, which only has to execute, which I was testing things on. Here's regular score, which overrides execute with the Score Manager add points. And then score by distance overrides that by taking in the distance, but also still calling the regular execute. Only difference is it takes in generate score by distance. And that was Score Manager. Alright, what else do we have? Let us see. We'll go into game modes real quick, because that really doesn't take too long. So here is my game manager. That's reset game. So here is start, which is called in the scene at the very beginning. Sets as the game type 1, which instantiates pretty much everything. So your HUD, it starts it up, player manager starts up, upon calling player manager starts up, it sets it all to be AI, because it creates an AI player and sets it to the current player. Sound manager starts up so that it sets it to mute. Grid manager so that it creates your grid. Wave manager to I forgot what that does, but that's to prep yourself to be able to load your wave data, and then you actually load the wave data. Instantiate your score manager to then be able to load in your high scores, and then you call your beacon wave, reset the color to black, and then you populate your mushroom field, and then you turn on the screen so that the mushroom field and the title screen don't overlap, and you call this thing called mode select. Now mode select here is just a very simple game object that destroys itself after being used, and it's only checking if a key is pressed. So if 1 is pressed, you get player 1 game, and if 2 is pressed, you get player 1 game silent. And essentially when you press player 1 game, you switch the game type to 1, turn off the title screen, so basically the whole fun list, swap your grids so that you're on player 1 grid, swap the players so you could gain control of the player, swap the sound so it activates, reset your wave, swap the wave so it takes out from the AI wave to the actual wave, and then you start the wave. The only difference in the silent mode is I simply commented out swap objects so that it doesn't swap your sound objects and it stays silent, so your ears do not burst from the sound of screaming. Now, with those two, I'm fairly sure you've seen me demonstrate going in between the extractor and player mode several times now. So let's just look into wave control, which we will continue in the next video if we do not finish it here. So wave control. Ooh lordy. Let's start from the very top. So very top of instantiation, we set all the pointers to false, not false, to null.